Choose one.
Okay, so I'm trying something new. I'm going to make a little video talking about the code. Mostly so I can go back and make sense of my own code, I think, in the future. But this is going along with my previous video that was kind of about how to use my game of life. Now returning to some of the source code, specifically the Babel, the actual writing of the React components and stuff like that make this app happen. So I'm going to go through some of this stuff and explain it to myself and others. But anyway, this is my main component, my main app component that manages most of the state for the entire app. Rows, columns, the board itself, which is a giant array, a state that I call number, which is actually the life factor number. I should switch that and name that better. Speed, that's kind of like another multiplier number for the speed of the evolutions, and then kind of like an evolution count. And then I also have a save board array for the. It goes in and replaces the state. It becomes board when you click it. And it holds a user saved array, which is basically a save board. This is all my bindings because I don't use any arrow functions really. A few times I do, but most of the time I don't. So I just do all my bindings. These are all the methods that are on this app class, and I just bind them all. Yeah, let's see. In our component did mount, I take advantage of component did mount to run my make grid function and set it to the state of the board. So I basically have a big factory here, and I've left some notes in. So our first thing, there's kind of like a chain function here. Um, I this is making the cell basically. Um, but right here, this is just a function that you can apply to something. And it does a math floor of math random times the state dot number. Basically, this function, and then it does a ternary end, and it's going to return um, true or false. Basically, is all it does, and that's going to determine if a cell is alive or dead. Um, and the way the math ends up working is you multiply a number, which is just that state that I've let it be adjustable by doing it. I could have just plugged the number in there and it would have been permanent. But the way you multiply math random by that, add one and do the math floor of it, and depending on like if your number is one, okay, math random times one, okay, so say math random was 0.5. 0.5 times 1 is 0.5. Take the math floor of 0.5, 0, add 1 to it, and you're back to your original number. The way the function works basically is if you put 5 in there, math random is going to make it so basically it has a 1 in 5 chance of equaling 5 on the other side. So you put 5 in here, goes multiplies by math random. If you put 10 in there, there's a 1 in 10 chance because there's 10 different numbers. Kind of hard to explain, but you need it for creating the cells. Then we're making rows here. Row is an empty array, and we take our state.columns and we run a loop, but we push the make cell into it. So basically, we get an array of true or false values. So if columns is 50, we're going to get 50 different um, 50 different values into that array. Now we make a grid. And okay, so we just made our columns basically, right? So we have 50, imagine 50 true or falses going down in a row, or going down in a column, one on top of each other, right? And now for the grid, for each amount of rows now, like going across or going down, each row goes across, but going down each row, that's also 50. So we're going to take an array of 50 true or falses up and down and push in and make one of those arrays for every row that we have, basically, is what's going on. So imagine, scratch what I said before. Imagine a true-false array that goes all the way out like this, and that's one array, right? Just an array of 50 true-false values. And now the grid basically calls the make row function as many times as there are rows. So now instead of one array of 50, now we have 50 arrays of 50. And if I change the row, this.state.rows to 20, we'd have 20 rows of 50, and so forth. So basically, this computes when both are 50. This essentially makes a huge grid of 2,500 true-false values based on the status. The frequency of true and false is going to be based on the status function, which is based on this.state.number. So if number's initially 5, like we set it to, each cell has a 1 out of 5 chance of being born alive. So when we create our 2,500 cells, we should get around 500. We come back to the game, we hit our reset function, 480, 508, 506, 471, 511, 491. So they're all right around 500. So you can see maybe that helps put the logic into perspective so far that I've used. And now we make yet another array. So grid.length at this point is columns times rows, essentially. So like I said, 2,500. So for all 2,500, okay, so no, grid.length is 50. Grid.I.length is 50. Each array is 50. It's 50 arrays. It's an array of 50 arrays, and each array within that array is 50 long. And then this is now pushing in JSX into all 2,500, and it's assigning a row and a column to each one, and it's assigning an alive prop. So like I said before, each one has its own status, true or false. And so here it's just going to evaluate the status, true or false. When it equals true, that prop is also going to be. It's really just passing the status to a prop, so we can conditionally render later based on that prop. And it looks like this video is almost up. This is proving a little more complicated to put into words than it was in my head. But hopefully this will make some sense as I keep going. Hopefully what I've said so far makes sense. A huge array. It's a huge array of true-false values. And here is where we pass it to a prop so we can conditionally render based on that prop later on.